Hello, this is our presentation for the Mtec video visual presentation, and this is the group 1, and our topic is about the parts of the sextant, errors of sextant, how to correct errors. First, this is the part of the sextant, and this is the sextant. The sextant has different parts, and these are index shades, index mirror, adjustment screw, frame, index arm, prismatic monocle, index mark, electric light, clamp, micrometer V-mirror, micrometer drum, arc, adjustment screws, and horizon shade, and horizon mirror.
Types of error. There are approximately 10 error a sextant may have, but only 3 of them are adjustable by the user. 2 need to be adjusted by the instrument manufacturer, and the rest are non-adjustable. In this module, we will only discuss the first 3: perpendicularity errors, side error, index error. The errors needs to be corrected in the order stated above. Perpendicularity. The index mirror must be perpendicular to the plane of the instrument. If not, then perpendicularity error is present. So checking for perpendicularity: remove the telescope or monocle, turn all shades from the mirror, unclamp the index arm and move it to the middle of the engraved arc. Clamp the index arm, hold the instrument in the horizon plane, and look into the index mirror in such a way that the true arc is visible to the left of the mirror and the reflected arc can be seen in the mirror. If the true and reflected arc appear in a straight line, then there is no perpendicularity error present. If the true and reflected arc are not in line, then error is present and needs to be removed. So we go for side error. The horizon mirror must be perpendicular to the plane of the instrument. If it is not, then side error is present. So checking for side error. There are 2 methods of checking for side error: by horizon observation, by star observation. So the horizon method is the quickest, but it requires a clear horizon. The star method is the more accurate, but requires more practice. When using the star method, a second magnitude star should be used because it provides a sharp point of light. A first magnitude star provides too much light and cannot be clearly seen. The horizon method is obviously used during the day, and the star method is for morning sights. Index mirror error. When the index arm is at 0, the index mirror and the horizon mirror will be parallel. If they are not parallel, then index error is present. There are 2 methods for checking for index error: observation of the horizon, observation of a star, checking for index error, or horizon method. The procedure is very similar to that used to be checked side error, except that the sextant is held in vertical position. Fit the telescope monocle to the sextant, set the index arm and the micrometer drum to 0. Hold the sextant in the vertical position and look at the horizon. If the images of the horizon appear in a straight line, then there is no index error. If the images are not in the straight line, then there is index error present.
Good day, sir. This is my report correcting index error on a sextant. To correct for index error, you first need to work out if it is present. Set the sextant to 0 degrees and then focus on something in the distance. The horizon is ideal. If the horizon looks continuous, the sextant has no index error. If there is a step in the horizon, index error is present. So this is the picture of the next slide: index error screw and the side error screw. So as you can see that visually, the index error is composed of 2 parts. You have the absolute value and you have the direction. To find the direction, we check whether the reading is on or off the arc. When a reading is on the arc, it means that you have moved on a graduations just as you would when measuring the altitude of a star. When a reading is off the arc, it means you have moved off the normal graduations effectively the same as measuring below the horizon. So this is the picture of the arc and on the arc. So that's all for my report.